Okay, so this time around we're going to talk about horizontal asymptotes. Horizontal asymptotes is a lot like the end behavior that we saw with polynomials. It's looking at what happens when x gets very large. Okay, so what happens when x gets large? That means the ends of our graph. So it's kind of like end behavior. Alright, so we're going to go back to this kind of funny polynomial notation that we saw last time. And the polynomial that's on top, p, it's going to be written like an x to the n, an minus 1, x to the n minus 1, blah, blah, blah. So the coefficients are a's, and the degree is n. So the numerator has degree n. The denominator is going to be a different polynomial, so we have to use different letters. So all the coefficients are going to be b, and the degree is going to be m. Okay, so the top is degree n, the bottom is degree m. Now, what happens when x gets very large? Well, we saw this with polynomials. Remember we said, okay, so ignore the bottom, just look at the top. We said when x starts to get very, very large, these other terms don't matter as much, and the polynomial starts looking like this first one, an x to the n. Okay, and by the same reasoning, when x gets really large, the bottom, these aren't going to matter very much, and it's going to start looking like bm x to the m. So when x gets very big, okay, we say x goes towards infinity or negative infinity, this is going to start looking like an x to the n over bm x to the m. Okay, each of those polynomials is going to start to look just like this. Okay, so now what good does this do us? Well, this simplifies things a little bit. It means that we're really concerned with what these degrees are. So let's see what happens. There's three different cases. If n is less than m, so if the degree on top is smaller, so we have like x squared over x cubed. Okay, if the degree on top is smaller, when x gets really, really big, this thing's going to get bigger and bigger and bigger and bigger. So it's going to be like 1 over 100, 1 over 1,000, 1 over 1,000,000, okay, 1 over 1,000,000,000. So this thing is going to get bigger faster, which means the whole thing is going to get closer to 0. So we say we have a horizontal asymptote at y equals 0. So I'm going to abbreviate that as HA. And we're going to say the horizontal asymptote is y is equal to 0. Okay, we'll look a little bit more at how this works in just a second. Right now we're just looking at the values. So when x gets big, this thing's going to get bigger, and this whole thing is going to go towards 0. All right, if n equals m, if the degrees are the same, if n and m are actually the same, these are going to cancel out, and we're left with an over bm, or an over bn, because they're the same thing. Okay, so if these actually match, all of this stuff is not going to matter. These are going to cancel out over and over again, and we're just looking at the leading coefficients. Okay, and then our last case, we've got n less than m, n equals m, so our last case is n greater than m. So the degree on top is bigger. If this is bigger, then when x gets bigger and bigger, this is going to keep getting bigger and bigger and bigger and bigger and bigger over something smaller. So the whole thing is going to keep getting bigger and bigger and bigger. And we're going to go to infinity, which means we have no horizontal asymptote. Oops. Okay, you can end up with something called an oblique asymptote. We are not going to talk about oblique asymptotes. So if you see that in the book, you can go ahead and ignore that for now. You'll cover that later if you need to. Okay, so if the degree on top is less, we automatically have y equals 0. If the degree on top is the same, we look at the leading coefficients. If the degree on top is bigger, then there are no horizontal asymptotes. Okay, so what does this all mean? Let's remember those three cases. Okay, so I've moved our conditions over here, the three things that we're looking for, and I've brought back this example from the last video. Okay, so we did x squared minus 1 over x squared plus 2x minus 3. We factored that, and we found that it had a vertical asymptote at x equals negative 3, and we found that it had a hole at x equals 1, and I graphed that for you. Now, if we can get the horizontal asymptote for it, then we would have an even better graph, and I left that off of the graph intentionally before. Okay, so for the horizontal asymptote, we're going to look at the degree, and it's probably easiest to look at the first version when it's multiplied out. You can see the degree a little bit better. So we've got degree, let me put this in another color. Okay, so our degree on top, remember that's the highest exponent. Our degree on top is 2. Our degree on bottom is 2. So that means that our degrees match, and our horizontal asymptote is going to be the leading coefficients. So we're looking at the leading coefficient over the leading coefficient. Those are both implied to be 1s, even though they're not written there. So our horizontal asymptote is going to be 1 over 1, or just 1. We've got a horizontal asymptote of 1. Okay, so what does that look like on the graph? All right, so we've looked at the vertical asymptotes in the holes, and we know that we have a vertical asymptote at -3. We already saw that. Looks like that. We know that we're going to have a hole at 1. We're just not really sure where that is yet. And now we know that we have a horizontal asymptote at y equals 1. So remember, when you have x equals a number, it's vertical. When you have y equals a number, it's horizontal. So we've got a horizontal asymptote at 1. So if you remember the 1 over x graph, it had a horizontal and a vertical asymptote. And so now we can kind of see the similarity here. All right, now again, we're still not ready to get this picture entirely on our own, but again, the picture looks like this. Ooh, hold on a second. Let me see if I can do that a little bit better. Okay, the picture looks like this. We see that L-shaped piece that we're used to. And then the other piece is going to be down here. L-shaped piece like that. Remember, we had a hole at 1. Okay, and now we can see that graph that I drew before. Now we can see a little bit better how it's defined, because we see that it's defined by those asymptotes, just like 1 over x was. Okay, let's see if we can do one more example. Let's say that we have r of x is equal to 1 over x plus 4. All right, now this one you should actually be able to graph as a shift of 1 over x. We've done this one before, but let's do it. Let's practice what we've been learning here. Okay, so we're looking for vertical asymptotes, holes, and horizontal asymptotes. Let's see if we can figure this out. Okay, so the zeros in the denominator, the only one that we have is -4. So let's put that right here. We've got a 0 at -4. And we've got to decide if that's a vertical asymptote or a hole. Does that 0 have a match on top? No, it does not. So it is a vertical asymptote. Okay, do we have any other zeros? Nope. So we don't have any holes. So none this time. Now horizontal asymptote. Okay, on top, this is actually degree 0 because there are no exponents. There are no x's, so there's no exponents. So this is degree 0 on top and degree 1 on the bottom. Okay, so we've got degree 0 on top, degree 1 on the bottom. So top is less than bottom. Top is less than bottom. So our horizontal asymptote is automatically y equals 0. Okay, let me take this example out so we've got a little bit of space to draw this picture now. Okay, so let's see if we can get this picture on the board. Okay, so we've got a vertical asymptote at -4. All right, so vertical asymptote at -4. And we're going to have a horizontal asymptote at 0. That's a little bit hard to draw, so we'll just kind of draw it over our x-axis. And so now we've got the skeleton of our picture. Okay, we still don't really know how to fill in the rest of this. And for that part, I'd like you to bring a graphing calculator on Tuesday, because that's going to make our job a whole lot easier. But you should be able to get all of this information and this much of the graph on your own. All right, so let's see. This is going to look like, it's going to look like this. and it's going to look like this, which you should remember from knowing the graph of 1 over x, and then this is going to be a shift of left 4. Okay, so that should be familiar to you as a shift, and then this is going through all the different steps for the other graphs that we didn't know how to do before. Okay, so that's the basic idea. We've got vertical asymptotes, holes, and horizontal asymptotes now.